Okay, so we are talking about APIs and how we can use these within our project and or just life, right? API stands for Application Programming Interface. Really, it's a doorway into somebody else's data and or code that they've created or used. You can think of things like Google Maps. That's a great API. Stripe API, which is like a payment system. So most people that want to, if you're using something like PayPal, using Stripe, Stripe's really popular. It's just a tool instead of me building a tool and interacting with Visa and MasterCard and American Express and understanding compliance issues. I could actually just use this tool called Stripe and it does it all for me, right? And I just make an API request. I send the data over, I bring it back. It is what we use it uses a process called the request response cycle. You guys probably remember this. Hopefully your instructor sort of hammered this into you, where we make some sort of request, and then it is passed over to a server or to an endpoint. An endpoint is just our unique URL. So here is my endpoint to bring up this piece of information, right? And so it's just my unique sort of specific place on the internet. Sort of think about it as an address. And we make some request. Hey, I want to make a payment, right? And so we'd send the information, the package in a response and saying, hey, I've got this credit card number for this amount, for this name, this expiration date, and this security code. Can you make a purchase to Visa or whatever card it is for this amount? We make that request and then they go through and they say, yep, that's great. It is approved. Or they say, nope, sorry, that either that card doesn't exist or the name doesn't match or, something, right? We don't understand what they're doing. That's that abstraction piece. We don't understand how Stripe works. We just know that it works. We can make a call and we get some sort of response. Get a 404, a 200 response means that, hey, yep, everything worked out great. 404 is like, hey, where you're trying to make this request, where you sent your package, that doesn't exist. We don't know where that's at. And so we use this request response cycle to interact with other pieces of information, other websites, lots of tools like that. Now, out of the box, just building the code and interacting with an API is kind of frustrating. It's kind of hard. And so there's a lot of tools we can use. One of them being something that if you took the JavaScript stack, then you're very familiar with this, being called Postman. If you didn't take JavaScript, then you didn't deal with this. Postman is an incredible tool. It's free, so you don't have to pay for anything. There is a paid version. Literally don't know what you use it for. I mean, from the paid perspective, everything you're kind of dealing with is free. Every company I've used has just used the free one. But it's a tool where we can interact with an API and see what sort of data we get back. So you can download this as an app. You could use the online. You can kind of do whatever you need to do there. There's kind of both there. I have it downloaded. So I'm going to open it up and we'll see sort of what we can do, how we can handle this, how we can deal with that as well.
We used Postman in Java a lot too. So any Java heads out there, you'll remember this.
Yeah. Yeah, Flask might be the only one that we don't use it with, which is an L on my part, if we're honest.
Yeah, I took Python first and then Java, and then it was like, oh, Postman. I'm like, dude, this would have been handy.
Yeah.
Well, we didn't even go for APIs. It was after our build exam. We just looked into it.
Yeah.
That's right.
Sorry, I'm signing in. Okie doke. Okay. So when I download it, it looks something like this, right? It is just an app, again, that allows me to make some request APIs. And this is a great way to test an API, right? We don't want to just code. Think about when we were talking about actually building out a question from an employer, right? We don't want to just go and code and just kind of like try to figure it out. We want to think through, process as much as we can and say, okay, what is the most optimal? What is the way to do that? Or, how can we do that? It's a lot harder to do it in code versus using a tool like Postman to interact with an API and just even say, well, what sort of data am I getting back? How am I getting that back? What can I use that for? So let's think about just an API. Swappy, which is the Star Wars API, is a great one to kind of practice, right? So let's think through kind of what this is, or let's look through this. This is the Star Wars API. It has a bunch of information about Star Wars. As you can see that if I were to look for people, this is what it sort of looks like. And most of your APIs are going to look like this, right? In the sense of maybe not look exactly like this, but it's going to show you what an expected return is going to be. In this case, there's a couple things that I want to make sure we're all on the same level. So let's kind of walk through what each of these mean. Let me get my little annotate tool and then we will be good to go. Where's my little annotate tool? My screen. And Zoom keeps updating and they're making dope stuff, but then they move all the annotate tools and stuff and it's just the most exhausting. Okay. Great. So here, can anybody tell me what this is called? What this portion right here is?
Like the root route.
Root route. There's another word for it. This is called my base URL.
Hmm.
So base URL.
It's very based.
Yeah. And then what we talked about is we talked about something called RESTful routing. Does anybody remember RESTful routing? Anybody want to give us and we talked about this, you should have talked about this in every
Yeah.
language, but yeah, any
RESTful routing is following like a convention that you
Mhm.
have your root route as, like this one is API. And then anytime you would deal with people, you're going to do a people. And then if you were pass an ID, it would always be people ID and then edit, or you're going to use the same thing over and over and build on top of it and also follow conventions so other people can see what you're doing and what you're trying to do.
Exactly. That's exactly right, Colin. Dude. Right on the head, right? Where we have our base. So again, we have this base URL and everything builds on that. And also we compartmentalize and follow certain structures. So just like Colin said, we've got our base URL. And if we want people, everything that has to deal with people is our base URL / people. And we can expand on that where we can put in the ID of a certain person. And if we had some other things that we wanted to edit them, so maybe it's people one edit, people one update, right? And we're passing some information, but we're just sort of building on to this URL. This is what we call RESTful routing. The reason we do it this way is because when we have an API, and this is most, this Star Wars API, they're not really making money on anything. I don't even think they have ads. So it's just some homie being a homie, right? Like just somebody who probably made a bunch of money being a dev at some big company. It was like, I'm just doing this for the people. They probably, host it on their own server or something like that. But a lot of these APIs, you think about like Google Maps, you think about Apple, lots of these big companies that make APIs. Twilio makes an API to text people to, lots of these companies, that's how they make their money is their customers interact with their APIs. And so we want to make sure that it's as easy as possible to interact, right? It makes more sense for everything to have a base route because if we had a different route for everything, imagine this was swappy people.dev.api, swappy people or swappy ships.dev.api. If it had all these different things, it's really hard to follow versus everything sort of being lined up. It builds upon one another. So hey, my URL, as long as I have swappy.dev/API people, then I know that I'm dealing with people, right? And I can assume and trust that. So if what I'm getting back has something to do with people, then I know, oh, oops, I wanted to deal with films, not people. So my URL or something like that's messed up. Our ease of use is huge with an API. We want to make sure we have ease of use because if people use it, if it's easy to use, people will use it. If it's hard to use, people won't. More money or more people that use our API, the more money my company makes. And so we want to make sure it's as easy as possible. Same thing with documentation. Good APIs will have really good documentation because, again, if I'm confused and I don't know how to use this, I'm just not going to use it. I'm going to go to something easier, right? We always take the path of least resistance, especially us developers. we're good at developing because we're lazy. We don't want to do something, the same thing every day. So we just automate it and then we don't ever have to touch it again, right? So this is our base URL and we can build upon, you know, if we want people or planets or starships, whatever. And then here we have an ID. This is just an example. Lots of APIs follow something similar, right? Where you have this base route. Now, this is an HTTP request. There's different types of requests for different things. And when we're dealing with like IoT stuff, there's one called MQTT protocol, which is another request type that we can deal with. They have their pros and cons, right? But HTTPS or HTTP is by far probably the most popular. And most of your URLs or your APIs are going to deal with an HTTP request. So why did I talk about Postman? Well, Postman's great because it lets us practice with APIs. Now, this is a built-in practice tool where we can make a request and it shows us something. So if I were to say people 3, it makes a request and I make my request. You see that now this is R2D2, right? And it has all this information. Not every API, most APIs don't do this. I would say 99% of APIs don't have some built-in request tool that you can sort of visualize and see. Again, this is built for us in a lot of new developers to interact with and test out APIs. But that's exactly what Postman does, is it's a tool that we can use to create a request and to see what it looks like. Cool. So there's different types of requests, and you guys remember this from your full stack languages. We have GET request, which just get information. What does a POST request do?
Packages information into the body of the request, typically a form, to securely send it to the user. So it's not in the URL. So it's not like, hey, your login is this and here's your password. Good luck.
Yeah.
Have fun.
Exactly, right? It packages some information. It can use a form like request.form, or you can get it from a form request, but you can, you know, it can package anything you need, right? If you're just taking a post request, you could do URL parameters. You can do a bunch of stuff, which we'll talk about that in just a second. There's also put, patch, delete. There's a whole bunch of different types. Really, the big 3 are like your GET requests. That's your default. So anytime you make a request to anything, most of the time it's a GET request. That's by default. Every API is by default a GET request. Not every API. I'm sure there's probably one API that's like by default something else, but usually when you're making a request, it is default GET. Post is when we're sending data. Put and patch, those are 2 different ones for editing data. One is I just want to edit this one piece of data, and the other is I want to edit the entire body of data. So if you've got a user, I just want to edit their age, or I want to edit their age, but I still have to pass in all the information and then delete, right? That's the one. I just want to delete this data. So here on this tool, we can go and we can decide which type of request we want, right? We want to get some information. So we're going to do a GET request. And then here is the URL that I want to make a request to. You can think of this as my API endpoint, right? So if I were to come here, I see that I can say swappy.dev.slash API. So I'm going to say https://swappy. As you can see, I've tested this a few times for students. .dev/API/people/12. Let's try this. And what this tool is doing is it's making a request to this API, and then it's giving me back a response. So I press send. It sends the request, and this is the response that I get. I get a response code of 200. That's good. I get a how long it took to get that response. with some additional information in there. And how big that response size is, right? Then I get the body. Now raw means this is what it will normally come back to. If you're, and I'm gonna now get out of this. Sorry, I'm gonna get out of the. I one gripe about Apple, not one, there's a few, but okay. This is normally what it's going to look like when we're dealing with an API. This is what we call a response. And more so, this is a JSON response, right? You're going to get a JSON, JSON response. And this is just a JavaScript object notation is what this stands for. But if you just see that this is a JavaScript object, that's what they're going to give us back. And we can do a bunch of stuff with this. If I've got this response and I want the name of this, let's say I call this, person equals, whatever this gives me back, then I could say person.name and it's going to give me this information, right? Or if I want to say, this is not a great one because I don't have films, but let's say we do 3. And here I have films, right? And maybe I want to iterate through all of their information. I can, I have this and I want to see what kind of films they have. Well, I could do that here. I make this makes another additional request, grab that information, and I can get, my film's name, or I can show all of this information on my page. Let's say I'm making a Star Wars fan page. I'm making a request and I can click on this. Maybe there's an image that we have. Let's see if there's an image here. It doesn't look like it, just film and species. We get it created at, last time it was edited or updated at, same. And then the URL of the request that we just made, right? And so now I can actually do something with it. Again, if I want to visualize or I want to show it, I could show everything I want, right? It's just an object. I can handle it and deal with it. This is what we call a JSON response. And so the power behind Postman is we can, before we actually code out and say, okay, here's my API, I want to make this request, I want to grab some information, I want to bring it back, I want to show it. We could first say, okay, let's pause. What does my API give me back? I want to make sure that I am familiar with the data or the response that it gives me back. Okay, cool. Now I have this and I know, okay, this is the pretty version, just makes it look nice. But I can say, okay, great. Well, I know what it's going to give me back. And then I can be like, okay, well, this response doesn't actually give me what I need, right? Let's say I wanted a photo of R2D2, right? And this doesn't have that. And so I might look at either another API or another tool, or I might just create an S3 bucket with all the photos of the stuff. And then I can build in my database, or if if I'm calling R2D2, then maybe I also make a request to my S3 bucket. S3 bucket is just a storage option, super cheap for AWS. And you can, lots of people store photos in there. Maybe I make a request there too. And then now I've got a photo and all the information there. Cool.
Hey, Will, so would
Yeah.
you do that by doing for this one, res.body, curly brace, films, and then the index, if one of those links was a was a link to an image of the film?
Yeah. So what you could do is you could also just make a request when you get this information. What I would probably do is if I'm doing this and I'm getting this information, once I get a response back that's 200, that's an okay. I'm checking for films, and if films is greater than 0, then I am iterating through that and then making a request each one and then storing that either in state or some piece of information, because this is going to give me, if I make this and I send this request, this is going to give me all of this, right? And so now I have access to all this information and I can show even, or maybe there's a couple of ways you could do it. Have it immediately, or maybe, there's like an additional thing that if you click on the film, then that makes a request with this film's information. And then it comes to another page that says, maybe I just at first get the name, which is a link. I click on it and now I get all of this information if I wanted it. Does that make sense?
Yeah, I got you. Thank you.
Yeah, absolutely. Again, this is a very simple one to mess with, but it's great. It's really powerful. It gets the job done. Now, if we were to go to something like a Google Maps, let's do Spotify. I think somebody said they're doing a vinyl. I think it's Nick. Is doing a vinyl store solo project. This could be cool, right? Where maybe with the vinyl, they could get a sneak peek or listen to a song randomly when they click on it. There's maybe, here's a playlist, right? We could deal with an API. Now it's a little bit different because the Star Wars API, you're not doing anything, right? You are just grabbing some information from the database. It's not really going to be like commercially used. You're not really going to make a ton of requests. And also whoever set this up has said, okay, great. Maybe they're hosting it themselves. Like I can handle as many requests as I can handle and it's free, right? It's fine. Now, when you get to other companies, again, money or using their API gives them money, right? And so they want to make sure that they get their money and they get paid. So they have to understand who is calling this API, right? What user is making all these requests? Because if I'm just using everything that they built for some commercial product, first off, I'd probably need some sort of license, but even for myself, what I need is I would need some sort of, they're not just going to say, yeah, just use our product and go make a bunch of money off of it. Don't pay us anything, right? They're going to say, no, I want to get paid for this. And so what other companies will do is they will require you to have like an access token or some sort of API key, which then allows them to say, okay, let's say they give me an API key of 1234. 1234 has made 500 requests this past month. Great. And then they would have some pricing tier that says, here's how much it costs, or, hey, it's all free, but once you get to 1,000, we cut you off until the next month, something like that. And so with that, they would give us I'm not going to click on this because I don't know if I already have one. I don't want there to be kind of unique information, but you can create this. Let me put this in chat. That way you guys can all test it. But you can get your app credentials, your API credentials, right? Where it's a user access token for whenever you're building your requests. Now you might ask yourself, well, what on earth is going on? You see that they use get, post, put, and delete. Those are there for, again, those are kind of the top ones. Here's the different status codes. So if you're playing with it and you're making a request, but you are getting, you're going to get some sort of code back. Just like in Postman, when it gave us a 200, everything's okay. Let's say you get a 429 that says, hey, you are requesting too many. Either their load balancer for their servers kind of overloaded, or hey, you're spamming this and that's costing us money, or that's, it's kind of putting a stress on our platform. They will rate limit you and say, okay, great. You can only do, let's see what their API. Yeah. So within a 30-second window, here's how many API requests you can get. If they might say, here's your rate limit. If you are here, then maybe it's too high or something like that, right? You've in the 30-second window, you've requested too many things. So they want to make sure that they prevent that from happening. So they'll put what they call a rate limit and say, hey, if you go above that, we're going to cut you off. And then obviously if you're building out a product and you're paying them for it, but you need more, that's when they say, oh, let's partner together and we'll get a enterprise package and we'll increase your rate limits and you can do all that. Think about like Tesla with Google Maps in their car, right? Same exact thing. Because Tesla uses Google Maps for their cars. So, yeah. So what they'll do is they'll give you an authorization token, and there's a whole bunch of different things. But this is a really great sort of walkthrough. Is the end user makes a request to the app. The app makes a request to Spotify. Spotify takes that request. If they can, they fulfill it and send back a response to my application. My application sends it back to the end user, and then they get whatever they want. This happens lightning fast, but they get whatever they want to get there. You can use, there's a bunch of different tokens or authorization types that they use. there's a whole bunch. API keys is again just your unique identifier if they would do that. Bearer tokens, OAuth 2.0, which is what they use here. And you notice that right when I do that, and I say OAuth 2.0, it says, hey, what's your access token? And if we were to go back here, one more, it says that we would get our access token in your API request. And so when we're making that request for Postman, we put that access token here. And then it's a bearer token or a bearer, there's different prefixes for what it would look like, but this is sort of packaging up a request so we can send that over. And again, this is just for testing abilities. Now, when we are actually dealing with the code, let's say that I wanted to get albums. I just want to get an album. Here's a sample of the request that we can use where we get, here's this, here's the album for this specific one, maybe the ID, whatever album has this ID. Again, here's my endpoint, my base URL is api.spotify.com/v1. I'm dealing with albums and then I'm passing in some ID, right? Here's the ID. I try it. I don't know what ES stands for. Whoops. Oh, I don't know what my password is. Anyways. Sorry, I don't know my Spotify password. I don't know any of my passwords. I use the password manager. So when I get that, I go, I don't know. So don't ever use the same password, just as like a heads up. Anyways, I will also have to pass in an authorization portion. And usually it's like it's in your request. Usually it's like a key, just a key value pair. So I type in my authorization. I type in, it is a bearer. That's just kind of what it's, bearer token. And then here's my token itself. And so when I make that request, I'm passing in that secure information. This is where we use a .env, right? If I'm making some sort of request on my platform, I am never putting this here. This is my unique token. If somebody gets it, then they can make just a bunch of requests. And if my credit card's on file, I'm the one who's responsible for the bill. Google does not care that, oh, somebody stole my API key, because they probably heard that a million times. And let's say you just run up your bill and you're like, I can't pay this. I'm just going to say it got stolen. That one, Google doesn't care, dude. They'll get all your money. That's all. You're on the hook.
We want your money.
Yeah, exactly. So this is where access tokens, API keys, those are things you put in your .env, and then you definitely put that in your get ignore. You never want that information leaked. It's a good idea to change it every 30 to 90 days, just to make sure, even if it does get leaked, every month you get a new one. Cool. Great. Worst case, that happens. Big companies, sometimes that stuff gets leaked and then it's happened for months and then they're getting this massive bill and they didn't even know because they just sort of paid it. So always make sure you're dealing with that. And then this is the sample that they get back, right? So here's, they would get the album type, total tracks, available markets, different things where they could deal with, if we wanted to visualize this, or all the different tracks, we can deal with artists. It's going to give you back, and then it tells you the type that you should be expecting. So even the ID here is a string. So that if you're dealing with a string, and this is really important. Let's say I wanted this ID to match something that was a number, maybe in my database that this was a number. If I'm looking at the response here, and this is a string, I need to know that I need to convert that, right? Because that's not going to work. So that's really why these sort of example requests are really important, or example responses, because it tells you everything you need and it helps you problem solve, right? If you're like, oh, my ID is a number, not a string, but I have it here, great. Or vice versa, right? Let's say they give me back a number, but I'm putting that in my, this is supposed to be a number and they give me back a string, that's an issue. Or if they give me back a number and this is supposed to be a string, that's an issue, right? So just understanding our data and how it flows is really important. Go ahead, Colin.
So is there a way to use one of these major APIs that obviously they know what they're doing, so they're gonna charge everyone who uses it? Is there like a test mode that's free? Or should we just stick to like Poke API and Star Wars API? Is there any way we could try to mess around with this and not have to get a bill?
Yeah, great question. Usually a lot of these, let's check, will give you a base amount. So like anything under 1,000 requests. I don't even know that they will charge you here because I don't see anything.
Yeah, I was wondering the same thing about Twilio. I was kind of reading on it a little bit.
Yeah, a lot of them will, let's see, rate limits, quota modes. Spotify is like what made them king was that they were really developer friendly. I don't know if you remember back in the day before Spotify blew up, they were all over Facebook and you could use like Spotify with Facebook. They might not even, let's see, quota modes. They might not even charge. Either way, like if we were to go to Google Maps, oftentimes there's rate limits that if it's as long as it's under, oops, telling you where I live. As long as it's under, you know, X amount, then like 1,000 requests or something per day, or let's see their pricing. Then they'll, you know, here, $200 usage every month for no charge. So you can get up to $200. So if you just wanted to test Google Maps, you have this. Yeah. So if you get this embedded API, unlimited, $0. So you can mess with this right here.
Cool. Do you think they want you to put in your credit card just in case?
I would guess.
Yeah.
I would almost bet my life on it. Yeah.
Yeah. Okay.
Yeah.
All right. Thanks, man.
Yeah, of course. Yeah, cool. So it looks like in the chat, Spotify is free to use. Yeah. So they just will rate limit you. But yeah, Spotify's pretty goated when it comes to APIs. So this is a way that we can sort of test with this. What we'll do tomorrow in office hour is we'll mess around with an API and get some ideas and test it out and see what we can get from information and can play music, or you know, maybe we'll mess with the Spotify one. Because it's free. So maybe we'll just mess with that and in Python or something, just say, because they showed it in, whoa, did I freeze? Okay, cool. Because they showed, we definitely should have known this in JavaScript, and sounds like in Java you guys did that. I'll do it in Python tomorrow. So that way all my Python people
Dude.
have an example of dealing with an API.
It would be sick to see an API dealt with in Python because I haven't done that yet.
Yeah. Yeah, there's a couple different ways that we can do it, but yeah, we'll build that out tomorrow.
So
Go
we're
ahead,
doing
Colin.
Google Map?
No,
API?
no. We're not doing Google Map. We'll do Spotify. Because I'll have to show you guys my token, and if my credit card's on the line. Not that I don't
Yeah.
trust you guys, but I'm not putting that in the ether.
You'd
Go
have
ahead,
to
Colin.
post to YouTube too.
Yeah,
Um,
exactly.
So I guess with all, like as we're getting more, as we're getting more experience and all that, would you say we should change, like, SQL Workbench? We have our password. If you're on
Mhm.
Mac, it's root. If you're on Windows, it's root. Should we like change all that stuff, or is that only local?
Yeah, that's only local. And that was created when you can change it. Just
Right.
Google how to change it. You can do that. They are sort of sunsetting Workbench because they're going more cloud based. It's easier for them and they make more money.
That sucks.
I know. That's why like Mac people can't even use Workbench anymore.
Yeah,
If
they
you
have
have,
to do
like-
their queries in VS Code.
Yeah, it's the worst. So they're trying to go everybody's cloud based because you can make more money because you have users. It's a whole bunch of stuff. Your valuation goes higher. It's like 12 to 1 per dollar that you spend on software versus having to deal with that other stuff, versus like hardware is like 5 to 1 if you're dealing with a company. So like if a
Yeah.
company sells hardware, for every dollar that they spend, are they selling hardware, investment wise, it's like 5 to 1. So it's worth $5. software is worth $12 because it's super scalable, really easy. You know, it's whatever. So people and cloud-based, they don't have to deal and manage. They don't have to deal and manage with like applications and stuff. It's just or the on
Libraries.
and also the OS in the sense of, oh, you don't have the most up to date. You have to download this application versus like, here's our cloud. You're just using this. We can make it agnostic to that. But I would say you
Okay.
can. But the MySQL database is on your computer. That's how people like. For instance, let's pretend that this is all in a MySQL database. This could, in theory, be on somebody's like Mac Mini or 5 Mac Minis in their house. And so a lot of people do like a home server and they just get a Mac Mini because they're cheap, they're fast. And then they'll just have, that's like their servers. And
Right.
so, you know, they've made it public, but yours is just on your computer. So you're
Okay,
fine.
so if we were getting to the point to where we're using something that's public and deployed, we probably wouldn't be using our own SQL database.
No, you won't be. No,
It'd
you
be
won't be.
something way more
Yeah,
advanced.
it'd be on AWS or Azure, or you would have a hosted. So like the way it, yeah. So you'd have it hosted. So there, you might still be using MySQL. It just would be on another computer somewhere in the cloud.
Yeah,
Okay.
you set
Like
it
an
up on a
emulated
yeah.
emulator.
Mhm.
Yeah, something like that.
Yeah.
With
Okay.
my
All right, cool.
experience in deploying with AWS, you basically have a virtual machine. It's a
Mhm.
Linux machine, and it's really cool. It's
Mhm.
fascinating. I love it.
Yeah, and you
Yeah.
could do it Linux, you could do it Windows, you could do it, like there's a ton of different, it's kind of, you can build whatever you want, right? They just have
Right.
servers and then they just say, set up however you need to set it up and we'll do it because we can do anything and they can.
Yeah.
So that's why they
And
made
that'll
billions of dollars.
right. So that'll be like its own separate thing, and at the time going through it, you'll set up your own
Mhm.
security password, and it won't even be
Mhm.
connected. It will be so if you're the one who makes it, but it really won't be tied to your own computer. It'll be
No, it
like a
won't.
virtual environment, a virtual machine,
Yeah,
something like
but
that.
usually you'll SSH in, which is a security way. So you'll think about like a remote login. And so
Right.
all that stuff will be saved as
And that'll probably even use a third-party service to do that too,
you
right?
can, yeah.
Yeah.
You can.
Okay.
So, yeah.
Need a lot
All
of
right. Thank you.
space for that too, right?
I'm sorry.
Takes up a lot of space too, doesn't it?
It can, yeah. Databases absolutely can. Now,
Also,
thankfully, space is cheap now. But
well,
yeah,
I'm
they
talking
can
about
take
more
up.
so the virtual machines.
Oh yeah, so that's where things have gotten abstracted to where it used to be like, oh, I'm gonna get a whole computer. But then now we've compartmentalized things with things like Docker. And so basically think about it like if you just have this application and and this is where Amazon's brilliant and cloud companies, they go, oh, well, Don Trail has this one computer, but his application is not that heavy. What if we compartmentalize them and, or a company Docker can do that, compartmentalize it. And then you can actually share a computer with Shane because his app's not that big. And so then one computer has all the right things and it shares it. And so then, it's better for Amazon. You pay less because you're using less. So that's one way. So a virtual machine or EC2 instance is an example of that. But you can even abstract it more. There's these things called Lambda functions, where basically it's like they think about it like turning on water, right? Thankfully in the US, almost everywhere you can open water and it's going to come out, right? It's kind of the cloud now to where I might not even need an entire application running 24/7 because maybe my user base is, in Zimbabwe, right? That's like all of my users are in Zimbabwe. Well, at 1 a.m, let's say I don't have anything, I can scale down or not even use a virtual machine. Maybe it's like barely running. And then once users start coming online, then it increases up, right? Or again, there's a Lambda function, which is like, I don't even need a whole computer. I just, whenever somebody makes a request, I need you to do something. And then they make a request and then the function runs for up to 15 minutes, does something, sends it back, and then it turns it off. So then you only pay for that 15 minutes versus 24 hours of holding. And there's a whole bunch of stuff I could talk about on the cloud.
It's like,
Go Go ahead.
It's like Amazon owns a bunch of apartment buildings and they're the landlords and they're making bank and we're all just paying for one little square of it. The multifamily homes, dang it.
That's exactly right.
Pretty much, yeah.
Yeah.
That's the
If you
cloud.
guys, if you guys didn't know, this is how internet works. It is all connected via pipes and not even, yeah, pipes and fiber optic cables around the world. So the way, and then obviously these connections are throughout the US and underground, but this is how literally how the internet works, is it's all just cabling all around the globe. Conspiracy theory is maybe this is why the ocean's heating up, because we're sending fiber optic
mean-
cable and tons of stuff through. I mean, that's a whole other
You
thing,
mean
but
There's literally cables in the water
all of, yeah, that's,
Oh,
that's
yeah.
how all the internet
all the way across
is
the ocean.
all around. Yeah. And then you can see the ones in yellow are all just the Amazon, Facebook, Google, and Microsoft ones. So, but
So
this is how
they-
the internet works.
That's so they literally put a wire, a physical wire from
A
one
fiber optic
continent
cable.
to
Mhm.
the other
Mhm.
in the water.
Yep.
That's insane.
Yep, this is how the internet works and gets connected. And then once it gets on land, you have it and then it spreads all over. So this is how the internet works. And so it really makes you think, like, when you make a request, I know we're about to get started with class, but this stuff just a second. When you make a request to something in the UK, it is literally traveling at wild speeds from wherever you're at to wherever their data center is and back in milliseconds, which is insane. But yeah, this is how the internet works. And then you have things that can emit it via Wi-Fi, so it hits podems. But this is how everything works. There's even a story, this is my last thing, we'll get started. A company paid, I can't remember how much, it was millions and millions and millions of dollars to run a fiber optic cable from New York City to Chicago, because they were a trading company and it gave them 0.08 seconds faster trading times. They received their data faster if they had their own fiber optic cable. And because of that, their algorithm could, even at 0.08 seconds, they ran the math and it would be more efficient. So they spent like tens of millions of dollars building a total fiber optic cable, just so that way they could get it 0.08 seconds faster. So that way they could make more money. So it is all in fiber optic. That's how the internet works. And then what all these are is just, there's data centers and they're just built, like you said, Colin, just apartment buildings that just host computers. It's like if everybody in an apartment building just lived on just had a laptop open and that's your application and people are interacting with that laptop, that's literally the cloud. So anyways, I just think that's fascinating. I love this visual from the New York Times. I just think it's so cool. So I'll put this in here for you in case you're wondering.
Yeah, cloud computing, I started looking into it a little bit more. And I've learned a lot of this stuff, but man, it is just wild to me that how it works.